got a clear agenda for today. So we are going to do about 40 minutes of discussion around data science ideas, different spaces in which data science is getting used. So this is something that is targeted towards people in their colleges who are intending to explore data science as one of the career options. It's one of the hottest skills right now, a space which is burgeoning with opportunities. So we'll talk about some of the relevant opportunities. We'll talk about some of the biggest applications of data science across different industrial and functional areas. We'll then spend some time talking about different kinds of roles that are available and what would be the best kind of role to start targeting as a college student to enter into the data science space. What would be the technical stack that is required to get into those kinds of roles? We'll spend some time talking about that as well. So we think about the major skills in data science. The three core skills in the area that you've got to explore. The first one of that skill is programming. The second core skill would be maths. And the third would be business intelligence. If you think about the core skills that exist in this space, these would be the three core skills that you would need to excel at or have excellence to a certain degree to excel in these areas as a data scientist. We'll talk about each of these core skills in a little detail. Now, when it comes to programming, you've got to understand exactly what is the level of programming skills that are required. Now, if you think about some of the popular choices in terms of languages that get used in data science, the few popular choices would be R, you've got Python, you've got languages like SAS. Now, SAS is a paid platform, something that helps a lot with data security, which is why industries like finance, banking, healthcare, they typically prefer to store their data and work on their data using a platform like SAS. Among the open source platforms, R and Python are two of the most popular languages of choice when it comes to data science applications. Inside that, Python becomes the most famous. It's become one of the most famous languages, at least in the last 5 years. As a result of multiple reasons. One, it is quite easy to use, easy to learn as well. Also, there's a certain level of versatility that you associate with a language like Python because of the simple fact that, Python is a language that gets involved right from some of the basic processes to some of the most advanced processes that are involved in a business, right from building a website to building models to deploying models. So if you think about a typical data science lifecycle, Python is something that can be helpful across different stages, which is why Python is one of the most preferred languages here. When it comes to the level of proficiency that is required in terms of programming to get in as a data scientist, that proficiency level would be somewhere between low to intermediate. The reason why I say that, there are roles in data science which would require you to really excel at programming, and those roles could be research analysts or AI experts. Now, these roles would require you to have a significantly high level of programming skills, but then these are not roles that you typically get into at entry level. So when you're trying to enter this space, when you're looking to get into one of the first roles in your career, it's important to understand the level of programming requirement that is required in this case. So among the popular technical roles, you've got software development as one of the major roles. The other major role in the last 5 to 10 years is data science. Data science has come up as one of those spaces which has a lot of opportunities, at least in the early stages, which means that you need to focus on the kinds of roles that are relevant at that stage. And if you think about that, that would be typically data analyst or business analyst roles. So business analyst roles. These would be the typical roles. We'll also talk about in details the exact technical stack that is required to actually excel at these particular roles. So the level of programming skill that is required for this is somewhere between low to intermediate. Even people from non-technical backgrounds who've never explored languages, assuming that you're willing to put in some 1.5 months of targeted effort into learning a language, the level of proficiency that is required is not too high. Most of the codes, most of the work that you do in data science is already modularized. They're written packages. You just need to pick, choose, and implement, which is why the level of programming or the level of programming acuity that is required to excel as a data scientist is not too high. So that's a good thing for people who are coming from a non-programming background. The other side of it is that people who have a good development stack as well as a good data science stack, they are able to pursue some of the most sought after roles in data science. Those roles could be called data engineers, sometimes ML engineers as well. Now, these kinds of roles are roles that you typically require a good deal of programming knowledge as well to excel at. These are some of the most highly paying profiles in data science, but at the same time, you need a relatively higher level of programming acuity, skill, acumen to actually excel at those roles. But at an entry level, some of the best roles, most approachable roles to target, which also pay very decently, would be data analyst and business analyst, for which the programming requirement is low to intermediate. The next core skill that is relevant in this space is maths. So there is a certain bit of mathematical rigor that is involved in becoming a data scientist. There are certain skills that you've got to excel at. Some of the core areas in maths could be statistics, probability, a fair bit of calculus, but very elementary level, which is why the kind of mathematics that is involved in learning some of the core ideas in data science are not to advanced level, which is why, again, this is something that becomes approachable for a lot of students. As long as you have a fairly comfortable, engagement with mathematical topics, you've had such an engagement up to high school, there's a good chance that, assuming you're putting in a certain amount of effort, you'll be able to cover some of the major modules. And again, we'll discuss in detail what is it that is exactly required at a data analyst or business analyst level to basically excel from a mathematical point of view. But as long as you you fairly balance yourself on the better side of mathematical abilities, you're good to pursue this as one of the spaces that you could explore. The third bit is business intelligence. The good thing is that this is something that you can only grow with experience. So this is something that grows with experience, which means that at an entry level, when you're right out of colleges and joining organizations do not have much of an expectation around this side. You being able to analyze how industries function, some of the core technicalities involved in companies and industrial roles that you must know to actually excel at that space, to analyze those processes and trying to improve those processes. The level of expectation in terms of business intelligence and being able to understand businesses and industries is not too high. You are able to develop it, though, partially through the help of internships, which means that the best way to show ability in this space is to first learn some of the core ideas that are required to excel at this space, and then pursue some relevant work in the industry. Go for some internships when you're in your colleges. That is the best time to go for these internships. There's so many companies in the market right now that they open data science internships positions. There are a lot that come on our LinkedIn page as well. We keep posting those opportunities on our LinkedIn page as well. You could just go ahead and follow that page, and that be some way you could get a lot of those opportunities out. But the simple idea is to first learn some of the core skills that are required in data science, and then apply those skills in the industry. At a college level, one of the best ways of applying your skills or applying your knowledge is through internships. So you look for opportunities where you're able to work with companies over a certain period of time on projects that involve an analytical side. There's some sort of analysis that you're doing on data, trying to improve certain process or trying to improve certain activities that are being run. And that can happen across different kinds of industrial processes, different kinds of functional roles as well. So as long as you're able to pursue the process of gathering knowledge and then being able to apply it in the market, in the industry, this is a space that is absolutely worth exploring. So in terms of what are some of the core skills that are really required to excel in this as a space, we talked about some of the core skills. What we'll now do is we'll again go back and we'll try and first look at a few applications to try at least get some favor of what is it that you can really expect out of this space, in the sense what are some of the common applications that the industry has seen for this kind, data science? What are some of the common areas in which data science has gotten applied? And in that sense, what we'll do is we look at some of the popular applications, and we'll do that. We'll look at some of the industries where something like this or data science ideas have become popular, and some of the common applications of those data science ideas in the industries. So we'll discuss that to get a sense of what is it that you can expect uh, on a day-to-day basis. What is it that you can expect to do in a data science role? To again give you a flavor of what this space is like. We've already spoken about core skills. We'll now try and correlate those core skills to some of the major applications of data science in the industry. So if you look at one industry at a time, and this is somewhere where you should really get a sense of how this is working. The first one, let's start with the retail sector. That's one of the spaces that has seen some heavy use for data science ideas. If we talk about some of the common projects, across retail companies, when it comes to selling different products, market mix analysis happens to be one of the most popular applications of data science, wherein you've got multiple channels, marketing channels through which you're spending money to get a certain amount of sales. Let's say you are a TV manufacturer and you're doing ads across the digital TV, social media channels, radio, newspapers. You're doing ads across different marketing channels, gauging the relative effectiveness of those marketing channels and understanding which marketing channel is contributing more to sales, which marketing channels are doing well, which marketing channels are performing better with higher ROIs or returns on investment on the marketing spend that we are making. So this is something that helps us get a sense of that. Market mix analysis, discount and pricing promotional modeling is again something that is quite popular. So as a company which is selling a soap at 14 bucks a piece, it might decide that it wants to start selling the same soap at about 17 bucks a piece, and would want to realize what's the relative impact on the revenues that it could see as a result of doing that. So increasing the price from 14 bucks to 17 bucks might result in a slight decrease in demand for it. There might be a few people who choose to do not buy it and buy a rival product that prices at the same point. But then that kind of modeling, what's the impact on sales that you could see? What's the impact on the business that you could see as a result of promotions, pricing discounts that you bring into certain retail processes? So that's one of the popular applications of data science in the retail industry. If we talk about the finance sector, credit risk analytics. So there's several people who get credit cards. So banks run models that help ascertain which of the different applicants for a certain credit card would actually be relevant people, would be people who do not default in the future, and would be good customers for the bank. And the bank tries to estimate that using historical data, looking at thousands of applicants who've previously applied for a certain credit card, and they've taken a decision to either give him a credit card or not give him a credit card. So models are run to do that. You've got stock price prediction. That's a very popular application itself. A lot of people make significant money out of the financial markets. That is something that can be done through analyzing stock market data, looking at how prices fluctuate over a period of time. So time series analysis is a major data science application that directly falls into the financial markets. Then you've got a lot of data science that's happening in the government sector as well. You've got public policy decisions to make. How many hospitals do you need in a certain ward? How many schools do you need in a certain area? These are things that you need a lot of data. Most of this data is primary survey data. So that again falls. So there's a lot of statistical work, sampling, and a lot of statistical work that goes into collecting such data. So a lot of public policy in that direction is affected by data analysis. So again, one of those spaces where there's a lot of application for data science. You've got several manufacturing companies that are doing heavy applications for data science in terms of trying to optimize their production lines. So companies have sensors through their production lines which take measurements of different. So let's say you're a company like Bosch and you're producing ball bearings of a certain dimension. You've got sensors all along the production line which measure these parameters at every fixed interval. They analyze this data on a regular basis to identify what's the failure rate in the machine, what are the number of pieces out of the total number of pieces that you produce, which are not falling in certain dimensions. So that's again one of the popular applications for data science inside the manufacturing domain itself. Then you've got domains like pharmaceutical. I think everybody has heard about applications for data science in pharmacy now. We've seen there's so much that happens in terms of drug discovery. There's so much that happens in terms of statistical trials. One of the most heaviest and researched applications for data science would have been in trying to be able to create an effective vaccine for the pandemic, for the coronavirus. In trying to do that, there's a lot of statistical trials and a lot of analysis that needed to get conducted, and at very fast pace it happened all across the world. So all the different drugs that ultimately get approved go through a systematic process of trials where there's a target group, there's a placebo group, where you push actual drugs to a certain number of people, see how they improve, and based on that, based on results, historical data, you try and analyze how well a drug is doing. So again, a large application of data science in healthcare and pharmaceutical industry. In fact, when you think about it, banking, pharmaceuticals, healthcare primarily, these are industries that are one of the most earliest adopters for data science. So even 100 years ago, when nobody was talking about machine learning and deep learning and neural networks and all of those things that we've now grown to so much wonder, and we consistently talk about it. Even 100 years back, when it was only statistical methodologies to deal with data analysis, even then these were areas where there was heavy data analysis. Banking has forever been using data science to efficiently improve some of the processes that they've been maintaining. So that's one area where you will see heavy applications for data science. You then got cybersecurity, so looking at visitors on your website, so looking at all kinds of threats in terms of time zones and where and how your different kinds of. So if you look at simple banking data, transactions that happen out of your time zone typically get flagged as fraudulent transactions. You typically get a call from the bank saying you made a transaction at 3 a.m. in the morning. Given that you live in India, it does not seem like a suitable time for anybody to try and make a transaction. If it's a significant size, you definitely get a call. Now that is something that is again data analysis at play. There's so much data that gets generated in some of these industries which get analyzed on a day-to-day level. Maybe 50 years back, we did not have the computational ability to deal with the kind of data that we are generating. But now, with advancements in hardware as well as software, our capabilities have increased immensely. We're still yet only processing maybe 2 or 3% of the total data that we create in the market. That is something that almost everybody has heard about. The growth of data. So the way the speed at which data grows is immensely high. It's exponential in nature, and the computational abilities don't increase at that level. Still, there's so much that we can process and we can take value out of, which a lot of industries are doing. So we already talked about a lot of industries. The purpose of doing this was to give you a sense of how different industries have sort of adopted some of the key ideas in data science. Now, it's quite common to realize that, yes, data science is something that has become a part and parcel of almost all industrial processes. The reason behind that is data science does not create a vertical of itself. It's not like a different industrial area. It's not something like banking. It's not something like healthcare. It is something that is part of almost all industrial areas. So it's basically a functional switch. So when you think about data science as a role, as a career, it's not about an industry that you pick. Yes, when you're actually targeting roles, you must look at what some of your primary and secondary domains should be. What are some of the industries that you would look to target? But data science in itself is a functional role, which means that it is something that you're now finding across industries, which is why it's so popular. The reason why this is a space that is burgeoning with opportunities, there are opportunities that keep coming in, it consistently keeps growing. The reason why that happens is simply because of the existence of data science as a functional role in almost all industries. What this page on your screen tells you is that no matter what space of the business or no matter what kind of business you think about, almost every business is interested in the idea of data science. And what's the fundamental idea of data science? Data science simply involves looking at historical events, looking at how events have happened in the past, and learning from them to be able to improve upon those processes. In any way, if you can analyze historical information and learn something out of it, the different kinds of analysis that are there. You've got descriptive analysis, you've got predictive analysis, you've got prescriptive analysis, you've got different kinds of analysis that you can make out of data. But the ability and the knowledge to leverage historical information to improve what you're currently doing or what we'll do in the future is what fundamentally data science tells us, which is why this is an idea or a school of thought or a way of doing business that has been adopted across all kinds of spaces. So that's more or less, something that was intended to give you a flavor of what are some of the industries, or what are some of the ways in which data science as an idea gets used across the market. So what we'll do is we'll talk about some of the core skills that are required to excel in these roles. And we'll also try and understand how these roles are different from each other. Now, from a technical point of view, these roles are one and the same. They've got the same technical stack as a requirement. What is it that you need to know? You need to know advanced Excel. When I say advanced Excel, everything before VBAs, even if you know VBAs, that is also something that is quite useful. VBA is a way of automating a lot of processes inside Excel. So a lot of tasks that you do in Excel could be automated using VBA. Now, that's one skill that is quite crucial in becoming, or making yourself justified for a role as a data scientist or a data analyst or a business analyst. You've then got to have exposure to one programming language. Again, like I mentioned in the beginning, the level of skill that you require in programming is somewhere between low to intermediate to become a data analyst. There are roles in data science where you'd have to excel at programming skills as well. But then generally those roles are roles that you typically pursue after 2 or 3 years of experience as a data analyst. So those are roles that require a certain amount of experience for you to actually pursue. But if you look at these roles, the level of programming acuity that is required is somewhere between low to intermediate. The popular choices here are R and Python. But if I were to make a recommendation on one language, that'd be Python. Python is one of the most languages, important, or one of the most popular languages, not just in terms of being a data scientist, but also if you look at any technical role which involves some kind of programming, mostly in almost all cases, you're mostly working with Python. So Python is one of the best languages to learn in that respect. The next skill that you will need is knowledge of some database management tool. Any tool that helps you deal with databases. What are databases? Databases are places where we store all of our data. Now, organizations have huge amounts of data. There's part of that data that they archive. There's part of that data that they keep in handy. So there are two popular places where you can actually store your data. You can either store your data locally on systems or Excel files. A lot of this has to do with data archival, or you store your data in clouds. On the cloud, you've got different kinds of databases. You've got all kinds of relational, non-relational databases. So you need to be able to deal with databases. You need to know one language or one tool that helps you deal with databases. So I can extract data, transform them, try and generate insights out of data, and be able to help businesses. Now, in that sense, one of the most popular languages or tools to learn is SQL. SQL is one of the most effective tools to deal with databases. Therefore, SQL, if you have this technical stack, that is something that is going to be extremely useful in trying to pursue a data analyst or a business analyst role. Beyond this, you need to have exposure to one visualization tool. Now, there's several good options here. Two of the most famous options would be Power BI and Tableau. So the programs that we offer that are targeted to college students have modules for both Power BI and Tableau. These are some of the most popular legacy languages. There's several good languages as well that have come up in the recent few years. Things like, you've got Amazon's QuickSight, you've got ClickView, you've got Google's Data Studio, you've got Periscope. There's several good tools, but if you think about it, these are two of the most famous and the vast tools in this space, which is why if you're comfortable with any of these tools, getting comfortable with any other new tool in data science is also not too difficult, which is why this is one of the best skills to try and perfect. And therefore, visualization is another major skill when it comes to a data analyst or a business analyst roles. What is left is now mathematical rigor. So you need to cover certain ideas in statistics. So you need to be good at some of the popular ideas in statistics and machine learning basics. So basics of machine learning. So there are some algorithms in machine learning. There are three major kinds of analysis that you can do with structured data. Mostly at a data analyst or business analyst level, you're not working with unstructured data. So if you think about data, data in itself can be categorized across structured and unstructured. Structured would be mostly what you see in Excel sheets, categorized in the form of rows and columns. Unstructured is more complex data. So let's say the text that is written in an insurance form, insurance claim form, or that be unstructured data in the form of text. You've got unstructured data in the form of digital data as well. So videos, images, audio, so all kinds of image recognition softwares and all of that. That's unstructured data. So mostly at a data analyst or business analyst, which is the kind of level that you should be looking at or pursuing at college level, you don't need skills in those spaces. You probably need basic level skills in machine learning, helping you deal with some of the common supervised learning problems and maybe an unsupervised problem like clustering. As long as you're fairly comfortable with these topics in mathematics, you again have enough of a technical stack to approach a data analyst or a business analyst role. So from a technical point of view, this is what you require. This is the requirement for a data analyst or a business analyst role. But then why are these roles different? Why do we call them either a data analyst or a business analyst? That's a common question that a lot of people have in their heads. Now, from a technical point of view, we already discussed that they are one and the same. The difference lies in where in the organization you get tagged to. So let's say you get tagged to the product side of the organization. You're dealing with features of a software product that you've built. So which features are doing well, which features are more popular among users, which features are not doing so well, which features are getting a lot of bugs and all. So those kinds of analysis, if you're conducting to try and improve products, you get tagged to the technical side of the organization. You're either called a product analyst or a data analyst. On the other hand, if you get tagged to the business side of the organization, dealing with day-to-day operations, supply chain, inventory, sales. So if you're looking at business data and analyzing business data and you align to the business side of the organization, that's when you get called a business analyst. From a technical standpoint, they're one and the same. But the side of the organization that you get aligned to, again, this is something that you can choose based on your interest. What you find more engaging? Do you find it more engaging to work on a product? Or do you find it more engaging to work with businesses, day-to-day problems? So trying to sort out, so let's say you've got a support center that you're running and you're getting too many calls during the day. You might decide that in, say, period between 1 p.m. to 3 p.m., you get a lot of calls in your support center, which is why you need to have more agents online at that point. Somewhere around 6 p.m. to 8 p.m., you don't get too many calls. At that point, you can shift it out in such a way that there aren't too many people in the call center at that point. With this kind of optimization, you could cut a lot of costs, you could maintain efficiency across teams. So there's a lot of scope for data analysis in both sides of the organization, both the technical side, which is involved with building the product and everything, as well as with the business side of the organization, which is mostly involved in dealing with some of the day-to-day business processes that are affecting the company. If you tag to that side, that's where you get tagged as a business analyst. So the kind of skills that are required to explore this space, we've discussed that to an extent. There's several other advanced level skills as well in data science. We'll try and talk about some of those roles as well when we come back tomorrow. But we'll mostly focus on how to prepare for placements, how to prepare yourself for these kinds of roles. What is the technical stack that you need to learn? What is it that you need to do from a resume preparation point of view? Some of the common do's and don'ts, we'll try and discuss those in the first bit, and then we'll also talk about how to actually prepare for interviews. What are some of the common things that get asked in each of these sessions? And that is how we go on with that bit.